In Japanese, konnichiwa, daisu. That is hello algebra. Lesson 10. That's the last lesson of at least the 2018, oh, for goodness sakes, and I still can't spell, 2018 school year. It's actually 2017-18 school year. Now, if you're not in the school year, there may be more lessons, so don't get your hopes up. For this school year, this is where we're ending before we prepare for our EOC, end of course exam. Okay, let's look at this. In a study of the activities of dolphins, a marine biologist made a 24-second video of a dolphin swimming and jumping in the ocean with a specially equipped camera that recorded one dolphin's position with respect to time. This graph represents a piecewise function, y equals f of t. So we've got the function, which is f of t, and the graph, which is y equals f of t. It's no big deal. That's just how we as math teachers signify what we're looking at. Y equals f of t that is defined by quadratic functions on each interval. So each color here is a different quadratic function. Different quadratic functions on the intervals, okay? It relates the dolphin's vertical distance from the surface of the water, height, to the time from the start of the video in seconds. Time. Use the graph to answer the questions below. Okay, we don't have any questions on this sheet, but as I fast forward to different slide sheets, you'll see the questions, and I copied the graph over so we could look at it. So first of all, describe what you know for sure about the actions of the dolphin in the time interval from 0 to 6 seconds, which is right there. Can you determine the horizontal distance the dolphin traveled in that time interval? Explain why or why not. It looks like at time equals 0, the dolphin exited the water. And then at time equals 6, the dolphin re-entered the water. We can't determine the horizontal distance because the function models vertical distance. Height is vertical distance. Our function doesn't model horizontal distance at all. It does not model forward movement. Okay, just vertical movement and time. We are not interpreting this as trajectory like we have in the last few lessons with a ball. This is not trajectory at all. It is vertical leaps and time. So you could almost picture it as if this is the ocean surface, the dolphin exits at time equals 0 and comes straight back down at time equals 6. Okay, time equals 0, boom, time equals 6. Okay, not forward movement. Where do you find the values for which f of t equals 0? Explain what they mean in the context of this problem. So this is where you have all the zeros. So f of 0 equals 0, f of 6 equals 0. We've got 0, 6, f of, what is that one, 16 equals 0. And then the last one is, I can't draw over there. Yeah, I can. Sorry, that's where my sort of toolbar is for my stylus. That is f of 24 equals 0. This is the time when the dolphin exits and enters the water. Oops, water. So it's at the water surface. At water's surface. How long was the dolphin swimming underwater in the recorded time period? Explain your answer or show your work. Underwater, let me erase these guys. Underwater is just from this time to that time. That's when the dolphin is underwater. So we're at time equals 6 all the way to time equals 16. So for a total of 10 seconds, the dolphin was underwater. Next question. Estimate the maximum height in feet the dolphin jumped in the recorded 24-second time period. Explain how you determined your answer. It looks like the dolphin reached that height at one point, but second leap out got a bit taller. So that would be our maximum height, right? So if I read that on a bigger scale, it looks like at about 20 seconds, the maximum height is approximately 23 feet. So we can say the vertex of that piece of the parabola is 20, 23. Locate the point on the graph where f of t equals negative 50. Let's see, that's 20, 30, 40. It looks like 50 is right there. Explain what information the coordinates of that point give you in the context of this problem. So we are at 11 seconds. At 11 seconds, the dolphin reaches a depth of 50 feet. All right, so that was our interpreting quadratic functions with graphs. Now we're going to interpret quadratic functions with tables. I find tables a little harder, but some people love tables just because it shows the numbers associated. You don't have to read the graph to figure out the numbers. So here we have a table below represents the value of Andrew's stock portfolio, where V represents the value of the portfolio in hundreds of dollars, and T is the time in months since he started investing. Answer the questions that follow based on the table of values. So it looks like our time is going up +2, and our value is going up and then down. I've got 325, I reach a maximum of 405, and then I go back down into losing money. Yikes. Okay, what kind of function could model the data in this table? How can you support your conclusion? I think it's quadratic. If anything, because it looks like we start at 325, we go up, we go back down as time goes on. So this would be time, this would be value of dollars. What else can I point out? Hey, we learned a long time ago, I didn't mean to scare you if I said hey too quickly, about first differences and second differences. Do you remember doing that? So if we subtract these two, let's see if I can do that with my calculator. 385, 325. I did not need a calculator to do that. I'm just going to go ahead and do a few of these subtractions. You're watching me do math, I know. 385 to 325. 225. We're going to show you something pretty cool here, if you're just a little patient. All right, that's our first differences, not constant. I'm doing second differences. Ooh. Oh. Ooh, look at that. Are you excited with me? Or did you fast forward? Look at that pattern. Isn't that exciting? Yeah. When the second differences are constant, we know that it's quadratic. Yay! And that makes me feel really good about our answer. Okay? Assuming this data is in fact quadratic, how much did Andrew invest in his stock initially? So we're looking for time equals 0. I'm going to look at the second differences that I calculated on the last sheet and see if I can find another pattern. Be right back. So if I look right here, I want when month equals 0. So if I go this way, I'm going to add 40. And then if I go this way, I'm going to get 225. And what's really cool, time equals 0, 225, looks like I am symmetrical with time equals 12, which is very cool. So I used my second differences to figure it out. And then we know symmetrically V of 0 equals V of 12, which is $225. Cool? Awesome. What is the maximum value of his stock, and how long did it take to reach the maximum value? That's another thing that I could have done. If I know my maximum value is at 6 months, which is 405, that means my minimum would be at 0, and my other minimum would match at 12, sorry, because we're symmetrical. So at V of 6, I'm at $405. So 6 months. And that's my vertex. If the pattern continues to follow the quadratic trend above, do you advise Andrew to sell or keep his stock portfolio? I don't like losing money, but it looks like if we're at 12 at 225, we're losing. It looks like we're going to keep on losing. 1, 2, 3, 1, 2, 3. We might go back up. Well, we're doing quadratics, so really at 0 we're at 325. We're going to 385, and then back down, 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 down. At some point in your math career, we'll learn about sine functions and cosine functions, which curve back up, but that's not what we're learning about today. So I would recommend sell. Initially, we did increase. But then we decreased. Because this is quadratic, we're not going to increase again. In real life, not quadratic, but it's what we're talking about today. How fast is Andrew's stock decreasing between 10 and 12? So we're looking at this set of data. And here we have change in y over change in x. This is our y value. That is our x value. So we're going to do 225 minus 325 over 12 minus 10. I'm at negative 50. per month. Are there other 2-month intervals where the rate of change is the same as 10 and 12? I'm looking for a $100 difference. Nope, that's really it. The only one, especially since we're negative at that point. Yay! I feel like we should have balloons and such, you know, exploding from the page, because that is it. And sparklers and confetti. It's a very exciting day. Congrats. You made it.